There are several ways to determine the zeros of the function f of x equals ax squared plus bx plus c. The goal is to find all inputs x where f of x equals 0, or equivalently, to find the zeros of the quadratic equation ax squared plus bx plus c equals 0. Note, a solution of the quadratic equation is a zero of the quadratic function. And remember, functions have zeros or roots, and equations have solutions. Using the zero product property. If m times n equals 0, then either m equals 0 or n equals 0. To find the zeros of f of x equals ax squared plus bx plus c, find the solutions of a factored equivalent equation of ax squared plus bx plus c equals 0. Ax squared plus bx plus c equals a times x minus r times x minus s. Here's a factored form of this equation there. So to solve this equation, the solutions are going to be positive r and positive s, because if you plugged in positive r for x, r minus r would be 0. And if you plugged in a positive s here, s minus s would be 0 as well. Note, this will only work if the quadratic equation factors into the expression a times x minus r times x minus s, or an equivalent. Here's the problem. Find the zeros of the quadratic function. F of x equals x squared plus 8x minus 20. First, we create the quadratic equation. So we take this portion here and set that equal to 0. Then we factor the left-hand side, x plus 10 times x minus 2. Then we use the zero product property to state that either this portion equals 0 or this portion equals 0. Then we solve for x and we get that the zeros of f are x equals negative 10 or x equals 2. The reason negative 10 and 2 are zeros because when you plug those numbers into the function, you get 0 as your solution. Practice. Find the zeros of the quadratic function. Alright, so we're going to factor this, but first we're actually going to write it into an equation. Our quadratic equation, set it equal to 0. Now we'll factor it, and we have an x there. This is negative, and this is negative, so there's going to be one positive and one negative term. And 9 times 1 is 9. Negative 9 plus 1 will give us negative 8. So negative 9 plus 1 equals 0. Therefore, x plus 1 equals 0, or x minus 9 equals 0. So x equals negative 1, or x equals 9. So negative 1 in here would make this 0, or 9 in here would make this 0. Alright, and we see that the zeros are negative 1 and 9. Moving on to the next one, we turn this quadratic function into a quadratic equation and set it equal to 0 to find the solutions. So we need to factor it. Alright, so 7 times 1 is 7, and negative 7 plus 1 will give us negative 6. So we have one positive and one negative, and we want negative 7 because this middle term is negative 1. Alright, so that means that negative 1 and 7 are the zeros. Find the zeros of the quadratic function. Alright, so first we're going to write the quadratic function as a quadratic equation, set it equal to 0, and then we're going to factor. So we have x and x. We know that there's going to be one positive and one negative because the middle term is going to cancel out, making these 4 and 4. Positive 4 and negative 4 equals 0. So negative 4 for x would make this term here 0, or positive 4 would make it 0. So 4 and negative 4 are our solutions. Alright, the next problem. Here's our quadratic equation equals 0. Let's multiply this out. So using FOIL, we have x squared plus 10x plus 25 minus 4 equals 0. We'll combine those terms. X squared plus 10x plus 21 equals 0. Continue over here. Now we factor that. So we have x and x. Both of these are positive, so we'll have positive and positive. And let's see, 21 is 7 times 3, and 7 plus 3 equals 10. So there we go. That equals 0. if we had a -7 in here or a -3 in here, these would both be 0. So our two solutions are -7 and -3.